Assalamualaikum warahmatullahi wabarakatuh. We are from group 4 and I will start for question number 1. So for question number 1, we will determine whether the assertion are true or false. So we must see here first the definition of big O, big theta and big omega. So for big O, it must have a lower or same order of growth, and for big theta it must exactly the same order of growth, and the last one is big omega must greater or same order of growth. So for question A, we see here n power of 2 plus n. So the biggest term here we will get n square. So for big O, it will give big O n square. It is the same with the biggest term here, so it is correct. For question B, is also the same from the A, which the biggest term is n power of 2, but it's using the big omega. So the big omega, as we know, it use higher or same order of growth. For this case, it used the same order of growth with the biggest term, so it's also correct. So for question C, n the power of 3, and it use big omega and n square. So for this, n power of 3 is greater than n power of 2, so it's also correct. And for the last question, for this one, it have to be expand first. After expand, we will get this, and the biggest term here is n the power of 2. For this question, it use big theta, which means it have to be exact and same order of growth. But for this, it give n power of 3. But here, the biggest term is n power of 2. So it will give false, because it should be big theta n power of 2. So this is all from question number 1, and we will proceed to question number 2.
Okay, I will demo question number 2. Okay, the question number 2 is to find the upper bound for the function 3n plus 8. Okay, as we can see in this function, the highest order in this function is n power of 1. And to do this question, we need to like this, and 3n plus 8 less than or equal to 4n. Okay, to get this 4n, we need to remove the constant and we plus 1, so it becomes true, and it becomes true 3n less than or equal to 4n. And then to get the notation, we need to divide with the n, so remove the constant and we got the notation on equal to 3n plus 8. And the c is from here, and the no from this constant, no equal to 8. Okay, so the final answer is the final answer is on equals to n.
Okay, next is question number 3, which is find lower bound for fn equal to 5n to the power of 2. For lower node, for lower bound, we need to know that there exists a constant, which is c is bigger than 0, and a value for n nodes, such as that for all n is bigger equal to n node, So we have Fn is bigger equal to Cgn. So for the equation Fn is equal to 5n to the power of 2, the Gn we can take here is n to the power of 2, which will we get 5n to the power of 2 is bigger equal to Cn to the power of 2. And next we need to find the value of constant here, C, which means C, and we can compare both of the equation both sides. So we get 5 here, and we will get 5n to the power of 2 is bigger equal to 5n to the power of 2, which means that n is equal to 1 is true. So from here we know that the lower bound for equation Fn equal to 5n to the power of 2 is n2.
Hi, today I would like to explain the question number 4. Okay, question number 4 is find theta bound for Fn equal to n square per 2 minus n per 2. So for n square per 2 is the quadratic term, and the minus n per 2 is linear term. Okay, for the n square per 2, the quadratic term grow much faster than the linear term. So the linear term, which is minus n per 2, will be ignored because of the n is large. So the answer for theta bound is n square. Okay, I think that's all from me.